Okay, we have a minute, but we'll just start a little bit early. So welcome to your third tech talk. I see you guys have lunch. So this one is about 10 things to know about Electron. And this is presented by Kevin. Also, please, like last time, keep your questions to the end so we can make sure that we can make it through the whole presentation, okay? Thank you.
Great, thanks. Cool. Thanks everybody for coming to this. I'm really excited to be here, and yeah, let's kick it off. So 10 things to know about Electron. So before we get started, my name's Kevin Sawicki. I work at GitHub. Been there for about 5 years, working on a bunch of things, one of them being Electron. Kevin Sawicki on Twitter and GitHub, and you can always email me at kevin@github.com. So before we get going, I'm just kind of curious, who here has actually heard of Electron, meaning the Electron framework, open source project? Nobody? Which is great. So no one's ever seen this icon before. It's kind of the Electron icon. If you've never seen it, it's good to know. So great. This should be informative and give you a great overview of this framework that is really useful for building apps. So the number one thing being, what is Electron? So here's the one sentence high level overview of this framework. So it's a way for you to build cross-platform desktop apps using web technologies. And so what do we mean by web technologies? We mean the three big ones, right? HTML, JavaScript, and CSS. So using Electron, you'll be able to build an entire desktop app using only these three languages. You won't have to use C#, you won't have to use Objective-C, you won't be using Java, you'll be using these three languages to do all of your entire app's interactions on the desktop. And Electron is built on these two core technologies. On the left, Chrome, or Chromium, depending on what you're calling it, and on the right, Node.js. So these are the two APIs that will be available to you when you're building an Electron app. So you'll have 100% of the APIs that Chrome provides. So XHR requests, WebRTC, all the newest DOM APIs, all the newest JavaScript APIs. Electron will provide you all of the things that Chromium provides. But also you'll be able to access any of Node.js's APIs. So how many people here have ever used Node.js before for building a JavaScript app? So it's just a framework like any other framework where it has file system APIs that you can access in JavaScript. It has child process APIs, socket APIs. It's just a JavaScript runtime that harmoniously integrates with Chrome inside of your Electron app. So both of these share a common JavaScript foundation, and you can use APIs from either when you're building your app. And just to get a little specific, currently Electron ships with Chrome 49 and Node 5.10. So it is a pretty new version of Chrome. Chrome right now is at 50, but Electron's a little behind at 49. So you'll be able to use all the features and all the awesome APIs that Chrome 49 and Node 5.10 provides you. And when we say cross-platform, we mean that you'll be able to write an app in HTML, JavaScript, and CSS that'll run on Mac, Windows, and Linux, which should have pretty good coverage. There's 32 and 64-bit builds of all of these, so it should enable you to kind of have a very wide audience for people using your desktop app. So who is Electron for? If you can build a website, you can build a desktop app. So the whole point of Electron is to abstract away all the complexities of building a desktop app and expose all of the great Node APIs, the Chrome APIs, and a bunch of other additional APIs that help you make your app feel really native when you're building it. You don't want it to feel just like a browser tab wrapped in its own window. You want it to feel like a native app with native interactions, drag and drop, bouncing the dock icon, notifications, all the things that we think of when we think of a native Mac app or a native Windows app, you should be able to do when you're building your Electron app. But you won't have to bring any native expertise to the party, right? You'll just be able to stay using HTML, JavaScript, and CSS to do all of these very slick native interactions. I should have probably mentioned this at the top. It is free and open source, so this isn't a product GitHub sells or some company sells. It's a free open source project. If you want to look ahead and go to github.com/electron, you can see all the code there. It was started by GitHub back in 2013, and it had its first release in 2014, and it was built kind of as an outcome of the Atom text editor. Has anyone ever used the Atom text editor here? It's kind of like Sublime, but a little different. So it was developed as part of that, and it's been around for a couple years now. And the tagline for Electron is oftentimes the hard part's made easy. So we want to take the difficulty out of desktop apps, and especially cross-platform desktop apps. So if you're looking to do something and you're not sure what the Windows API is for it, what the Linux APIs are for it, and what the Mac APIs are for it, Electron papers over all of that for you and gives you a common foundation where you'll have expected native behavior for your app with a single API that should be pretty easy to use via JavaScript. So how does Electron work? This will just give a brief architecture overview of Electron to kind of see how the pieces lay out when you're building your app. So every Electron app has what we call a main process, right? And that's a process that is basically when your app gets launched, you double click it, it shows up in the dock, and your main process kicks off. And each main process has, as I mentioned previously, access to the entire suite of Node.js APIs. So your main process can read files off the file system, can open connections to remote endpoints, can spawn child processes, all those great things. It also has a bunch of additional APIs that are custom to Electron, things like dialogue. So say you want to show an open dialogue when your app launches because you want to prompt the person, what file do you want to open? We have an Electron API for that. It also has things to make your app feel more native, like system menus, context menus, and throwing things in the tray area of the OS. And each main process, once it's kind of ready to go, it'll create what we call a render process. And that's actually the physical window of your app. So when you're, it's the part of your app that has the buttons that have, close, minimize, maximize. That's your render process. And the main process instantiates that and kind of tells it what to do, what URL to load, what content to show, and how to show it. And these processes communicate with each other over just a very simple JSON-based inter-process communication, so you can send and receive messages. So when your main process kicks off, you say, oh, what window should I show? Maybe I'll read the last saved state when my app shut down. I'll relaunch the window. I'll put it in this location. I'll set it to this size. And I'll tell the render process, start showing this content. The render process has its own node context and also has access to the DOM, so all of the Chrome APIs. So because the render process is a window, it has full access to all the JavaScript DOM APIs. You can say document.write. You can say create new HTML elements, render them on screen, read styles, set style sheets, all that stuff. We also have full access to the Node APIs. And the two Node processes, the two boxes for Node are each in their own sandbox. So the render process and main process don't actually share any Node globals. They each have their own version of Node.js. And you'll notice also that there's no DOM in the main process because it's not actually a renderer. It's just a process that kind of bootstraps your windows. And this will all become clear as we kind of go through some examples. This is the basic architecture. So if you've ever, I'm sure you've used Chrome or Firefox or something else, and in the typical sense, when you have a lot of tabs, one tab can crash and it doesn't take down the whole app. And that's the same kind of model in Electron where one renderer process could go awry, could hang, could crash, and it wouldn't take down your whole app because your main process is managing these windows, and your app can also have multiple windows. So depending on what interactions you're looking for, you could spin up multiple windows, you can hide and show them as things come up and go away, and they can all talk to the main process and to each other through a very simple IPC layer. So how does your Electron work? So say you were building an Electron app, how would you actually go about building that? And the big thing to know here is that Electron is not prescriptive at all about how you build your app. So there's a million ways to build web apps, right? Especially ones that are JavaScript heavy. Basically anything that runs HTML, JavaScript, CSS in Chrome and using Node APIs is what you'll be able to use in your app. So you really become the architect of your app, and it can really be a choose your own adventure of how you want to actually build it. So say you're interested in building your app in React, Babel, and Browserify, which are very common, popular projects. You can just go for it, right? There's nothing in Electron that forces you to use React or disallows you to using React. In its sense, it's just a browser, so anything that works in the browser will work in your Electron app. Say, perhaps instead you want to use Angular, you want to use Bootstrap, and you want to use Webpack. That's fine too. That's another totally different stack of things that you can just use and will work just as they would in a tab in Chrome or a tab in Firefox. They'll work inside of your Electron app. Or what's really interesting about Electron apps is you can just enjoy the purity of Chrome, right? Because a lot of these frameworks paper over irregularities and differences between all the browsers out there, right? So they're doing things for Internet Explorer, Firefox, and Chrome, but because your Electron app runs one very specific version of Chrome, you can use just what that API provides and stick to a very, very very homogeneous environment, right? You're just writing against one single browser. You'll always know all of the people using your app will be on a specific version of Chrome, and so you don't have to worry about browser compatibility. And you can also use some of the great things that have recently shipped in Chrome. So Chrome now has support for custom HTML elements. So now, kind of like how you usually use a view framework to do a lot of your custom elements when you're building complex UIs. Now you can do that all through the Chrome APIs that actually allow you to have full-blown lifecycle events for all the HTML elements in your page. There's also CSS variables just came out recently in Chrome. So if people have used like Sass or Less or other like preprocessors for CSS, now you can have variables inside your file. So say, for example, you want the padding to be 10 pixels and everything in your page, and you have it strewn throughout your style sheets. Now you can have a variable that's called like my padding, and if you change it one place, it'll change in all the different selectors that use that variable, which is really, really nice, right? It allows you to use a very common practice of why people typically use other styling frameworks like Less or Sass. Now that's built directly into the browser, and you can make use of it in your app. Also, Chrome has amazing support for ECMAScript 6, so if you want to use any of the awesome new features in JavaScript, the language standard, they most likely work in this version of Chrome, and so you'll be able to not use preprocessors or precompilers for your JavaScript. You'll just be able to use the latest and greatest JavaScript features out of the box with no additional hacks required. One of the other big piece here is because Electron supports Node, you can use any of the 273,000 packages that are published to the NPM registry. So if you went to NPM right now and you search for any number of packages to do something that you want your app to do, you'll probably find a bunch, and they'll all work in Electron because Electron runs Node, and so any package that's been published here, you can just use in Electron without modifying it. And also you choose when to upgrade. So if you think about some of the annoyances you may have had doing web development is that you have to, when you're often thinking like, when can I use this thing, or when can I drop support for this old thing because no one is using this browser anymore. But when you ship an Electron app, you control the entire experience around when the user moves to a new Chrome version inside of their app. So say you want to keep on Chrome 49 forever, you would just pin your app to use one specific version of Electron, and you would never deal with having to upgrade Chrome again, and you'd just be able to have your app consistently work forever. But as new Chrome versions come out, we ship a new Electron version with that Chrome version, and so you can also test upgrades before you deploy them and make sure your app is still in working order before you upgrade your users to that new version. Another great thing that I kind of touched on a little bit recently, but we'll go deeper into now, is how Electron apps can feel native. So this is an Electron app right in front of you. So it's a really simple app that just shows you whether or not all the sites you typically rely on are up or down. So as you see, it's a little popover, and we see GitHub is up, Heroku is up, NPM is up, RubyGems is up, Travis is up, New Relic is up. It's a great day, right? All these things are not down. And this is an app I built just because I was constantly checking all these status pages when some things I would see the build break, and I'd be like, oh, is NPM down? Is Travis down? A lot of these services rely on each other, so it can get very annoying when one of them goes down. And usually when GitHub goes down, which we hate to see, other things go down because they depend on GitHub. So I wrote this app that just simply hits their API for their status page and just renders the results right here, whether it's green, yellow, or red. And so let's deconstruct this app a bit about what makes this app feel native. So one is it's using the tray API. So if you can, let me get the little dot. So if you notice that in the system notification area of macOS 10, Electron apps can put an icon, right? And get events when that icon is interacted with. And that will work on Linux and Windows as well. So if you want to build a like a multi-platform tray bar app, you can do that with Electron. And there'll be just a simple JavaScript API for you to say, put this in the toolbar and notify me when it gets interacted with. You'll also notice this is a frameless window, right? So that's another thing you can do in Electron. Like, it has no Chrome, right? It doesn't have the stoplight dots on the left, or if this was a Windows app, it doesn't have an X. It is frameless. So you can tell Electron that I don't want my window to have a frame. I want it to look kind of like a popover of sorts. It's also a transparent window, right? And I wish I could zoom, but if you look right there, you'll notice there's a little tail on this window. And I'm actually drawing that using CSS. So this is a transparent window that I can draw a custom Chrome on. So say you want your app to be a circle. you can do that because you can just say I want a transparent window and I want in CSS to say it looks like a circle, and you'll be able to do that. It also has access to notifications. So another thing this app does is that when one of these services go down or up, it shows you the standard OS notification about what's happened. And so that's another thing you can do in Electron apps is put notifications in front of the user and know when they get clicked and everything. And also, I'm using this really cool open source library called Photon to make this app look really native. So this, I think, looks pretty normal for a Mac OS X. You know, it's got the Mac buttons, it's got the Mac Chrome, but all of this is done in CSS. And nothing you see here is using a native rendering layer. This is all just divs and spans and button groups and all that stuff. And so it's using this library that someone wrote to make, it's just a very simple Mac style sheet that you can apply to any app, whether Electron or not, that just makes, instead of it looking like a Bootstrap app, it looks like a native Mac app. And so I just dropped that in and then went away and started styling things. And just to really quickly go into the code of how you do that, it's all JavaScript, so this is kind of the code that would run in your main process, as I talked a little bit about at the top, right? And you'll see you just do a simple require Electron, and you can just access the APIs off it. So in this example, I'm using the browser window API, and I'm creating a browser window with a width, a height, no frame, not resizable, and transparent. And that kind of makes the initial look and feel of my app. And then I also say, load this URL. And then Electron will just say, okay, I'll create a window for you, and I will load this URL as its regular page, and then it'll load and people will see it. And then you can also attach other native events to it. So when this little widget loses focus, let's hide it, right? Because that's like a typical thing when you click on something in your taskbar and then click to something else, that thing in your taskbar just goes away. So I can listen for a blur event on the window, and when that runs, I can just say, let's hide it. And the second piece of this is that tray API that I was talking about. So again, I just say, I bring in the tray API from the Electron main level module. And I say, one thing you have to give a tray is an icon or an image to show in that tray. And then when it's clicked, if the window is visible, let's hide it. Else, let's show it. And so when they click it once, it'll show that popover. When they click it again, it'll go away. Pretty simple interaction, but it feels native. And theoretically, the person that launches this app will not say, oh, this looks like just a website repackaged as an Electron app. No, it'll feel native, and it'll look native, and it'll kind of meet their standards for a native-y application. Some of the other APIs that you'll probably want to use to make your app feel native, one is you can take screenshots. Another is that you can access the microphone and camera without prompting the user. So typically your browser runs in a sandbox, and you have to ask the user, oh, can I know your location? Can I access your camera? Can I access your microphone? Because Electron's a desktop app, we enable all those APIs for you without prompting the user. So your app starts, and you can immediately say, I'm going to start listening on your microphone or taking pictures of you with your camera, and it'll just do that using the standard HTML, JavaScript APIs for that. You can also use native dialogue. So say you want to show a save dialogue or an export dialogue or an open dialogue. Electron has cross-platform APIs to do all of those using the standard native look and feel dialogues that you would expect in other apps. You can also add context and system menus. You can also register global keyboard shortcuts. So say I wanted that status bar widget to show when the person clicks Command-Shift-Alt-S. I could tell Electron that even when my app is in the background, if the user runs this keyboard shortcut, send me an event that'll then tell my app to show. So you can make your apps really quick to launch. If they're little utilities, you can do that all using the global shortcut API. You can also prevent your computer from going to sleep. So say you're writing a video player as an Electron app. You don't want, the person probably doesn't want the machine to go to sleep when they're watching a video. And so you can actually tell Electron, using the standard native APIs, don't go to sleep until I tell you you can. And another big one is that you can actually report crashes. So say something does go wrong with your app, you will be able to access those crash reports and send them to yourself as an email or something and know what went wrong with your app. The big piece kind of touching on that is that also Electron makes debugging easy. And it does that because since it's Chrome, it has full access to the Chromium dev tools that hopefully everyone has seen at some point. Is, if you run Command-Alt-I in Chrome, it'll pop open this amazing panel that allows you to completely inspect your app and see everything it did, all the resources it loaded, how long the network connections took, all the styles that were loaded, all the event listeners. And so you have that same entire experience inside of your Electron app because Electron ships with the Chrome DevTools. So you can set breakpoints, you can have full access to a JavaScript debugger where you can inspect variables, and you can tweak the code, live edit it, and hit save, and it'll reload it, and all those great things that kind of you typically use when you're developing a web app. You'll still have access to do that in your Electron app. You also have access to this awesome render timeline, which you may have never seen if you're doing web apps that are not really heavy interaction based. But say for example, you write a little Electron app that has a list that keeps scrolling, and you want to look at the render performance when the person kind of flicks the page. You'll be able to do that with this render timeline, which will tell you all the times Chrome is painting, it's updating styles, it's kind of dispatching events, and you can kind of see where the lag in your app is and how much time is spent in each frame running scripts, rendering, painting, and other stuff. And this is a great tool if you've never used it. I highly recommend it to debug performance problems in your app. And another, probably my favorite one of the Chrome Dev tools is the heap snapshots. This is a way for you to kind of look at all the objects in memory inside of your Electron app. And you can find memory leaks really easily through this. You can see like what listeners are getting registered but never unregistered, and so they're sitting on the heap, and they're taking up memory, and they're not being kind of garbage collected ever. And so this is a great tool to kind of help you find out like what object is holding a reference to this object, preventing it from being garbage collected. So if your app is getting slower over time, this is a great way to kind of find memory leaks and see whom the culprit is. And this is great. So if you think about other desktop app experiences you may have had, like using Java or using Qt or using some other native framework like Mono or Objective-C, like all of these tools require your app to either be like rebuilt or restarted, or you have to have a custom debug build that you send to the person to try. But with an Electron app, if a user of your app is reporting a problem, you just tell them, pop open the dev tools, take a heap snapshot, email it to me, and I'll take a look. And so these dev tools are always available, they're always running, and there's really no work you have to do to help debug your app. Once it gets out into the world, you can actually tell people like, oh, I want to get a little more information from you. Can you open the dev tools, go to the console tab, run this little thing, and send me the results? And it's a much greater experience than having to tell them like, oh, get on this beta channel build, and then like start it with these flags, point it to these symbols, all that stuff. And you can also bundle and ship additional extensions. So there's also an API to the Chrome DevTools. So say your app has some custom interaction that you want to write a custom kind of inspector for, you can bundle it and ship it, and it'll be available in your app when it gets into everyone's hands. So another point to note is Electron can be test-driven. So this is probably something you may have never done when you're writing a desktop app before, but Electron supports WebDriver and Chrome Driver. So who here has ever used like Selenium or WebDriver or something else to kind of test drive a HTML page? So a little brief introduction if you've never heard of WebDriver. So it's an open source tool for automated testing of web apps across many browsers. So it allows you to kind of, it's a protocol that many browsers implement that say like, send me commands, and I'll do those commands, and I'll send you back the results. And so Chrome Driver is a server that implements this protocol. So Chrome Driver is the implementation of WebDriver for Chrome apps. So say you wanted to drive your browser and say, open a tab to this. When that tab loads, set this input field to this value, and then click this button. You can do those things with WebDriver and Chrome Driver. But what's really nice is because Electron is based on Chrome, you can also do those things with Electron apps. So say you have a little app, and we'll call this app, for this example, we'll call it Phony, and you wanted to test it completely externally. So this isn't a unit test that runs inside your app. This is an actual test that launches your app and then externally probes it with, like, it sends it commands and then it reads back results. Right, and so we start the app, and so at this point you would see it like bouncing in the dock icon because it officially loads, and then you can say, oh, I want to set the value of this selector to 911. So this is like an input field, theoretically. So this is an element in your app, and you want to say, oh, make the value 911, and then click the call button, and then let's get the text of the progress bar. And when that all returns, we want to say like, oh, well, in this test, for example, we would expect that the text of the progress bar to be dialing 911. And so this is a great way for you to write assertions that kind of probe your app externally and make sure that it launches correctly, it persists state correctly, it does all these things. And what's great is because Electron is just built on top of Chrome, there's a lot of great libraries out there that have really nice test scaffolding to make your app really testable externally. And this is one such library called Spectron, but there's a lot of others out there. And this is just one of the many things you can do with your app to kind of, verify that it's behaving correctly. So now I'm going to kind of go into some of the Electron apps that you may be using already and just not knowing that they're Electron apps, and kind of show you kind of what is out there already and what cool things they're doing. So if you've used any of these apps, you've already used an Electron app. So Slack is based on Electron. So I assume has everyone heard of Slack? Okay, cool, yeah. So Atom, which is a text editor that I mentioned, is also based on Electron. Has anyone used Nihilus or ever heard of Nihilus? So it's a really cool, free, open source email client that allows you to kind of like customize. It's a much better email client. So it's really polished, really nice, really fast, but also has like an API. So if you wanted to like write custom extensions to your email client, like little snippets for quick replies, or little little like extensions to help you do things faster, send email faster. Has tons of APIs to do that. So the company is called Nihilus, and the email client is called N1. It's on GitHub. It's, like I said, free and open source, but it's a really, really polished Electron app that has some really complex user interactions. Another one is Visual Studio Code. So that's like the new version of Visual Studio. That's cross-platform. That's based on Electron as well. Just going to go over a couple more. This is a really cool one that came out a couple weeks ago. It's a web torrent client. So it's basically like a video player that is torrent based. So you can do your thing there, and you can watch videos, you can queue up videos, and it's all based on Electron. Some of the great things about it is that all of it's implemented in JavaScript, so it's kind of easy to contribute to. It uses WebRTC, so like it talks to other versions of itself running out there using peer-to-peer connections, using the WebRTC standard, and it's also free and open source, and I highly recommend checking it out. This is probably my favorite Electron app. It's this robot that runs Electron. So this is simply a website running inside this robot's face that you can program to do all sorts of things. You can talk to it. It's kind of like a Siri or an Alexa kind of thing, where you can like ask it how the weather is. You can make it dance and stuff. But it's a Jibo robot. If you've never checked it out, it's a really cool robot. It's a great example of using Electron to make all of this like web accessible, so people can extend it, write their own plugins, all that sorts of great stuff. And these are some of the other awesome Electron apps. If you go to the Electron site, you'll see all these icons, but there's a lot of them out there, and we're kind of adding new ones every day. So onto the community side. So Electron also has an amazing community. So I said it was free and open source. So it is kind of widely used. Those companies like Slack and Microsoft kind of contribute a lot back to it for the apps they're building. It has had some great traction on pull requests, and roughly 800 or so packages are just for it on NPM. Like, people have built Electron libraries and published them to NPM already. So there's definitely a ton of valuable libraries out there for you to kind of get your app going, whether you want to start using React or Angular. There's a lot of good boilerplate apps that help you get your app up and running. This is probably my favorite, right? It's this app called Natifier, and basically it's a command line that you just point it to a URL, and as it kind of loads it, it makes a native app version of that URL. So say, for example, you want, there's this page you use all the time in Chrome, right? And you're like, if only I had a native app for this. Well, this allows you to quickly make just a standalone native app that all it does is load that URL, and it can sit in your dock icon and do its thing. So it allows you to kind of have a standalone app for any website you commonly interact with. And it does really nice work with like figuring out what to name it, figuring out the icon. And if you notice, this person built a WhatsApp app using this Natifier app. So it's pretty cool. And there's also this great list. This is like a GitHub repo. It's kind of hard to fit the URL, but if you Google awesome Electron, you'll find like a giant list of all these really cool libraries, frameworks, and apps that use Electron, as well as videos and articles, all sorts of stuff. And for the people in the Bay Area, we're also doing a Bay Area Electron User Group meetup next month, May 25th, at Microsoft's San Francisco office. It used to be the old Slack office. It's a pretty nice space. It's on meetup.com, so you just like search Bay Area Electron, you'll find it there. Always looking for speakers, always looking for more people to attend, so if anyone's interested, it's next month. And just my last point is that Electron is going 1.0. So Electron's been out almost 2 years, it's matured a ton, it's had a ton of fixes and stability work, and now we're really, really close to going 1.0, which should mark like a major milestone in the framework's maturity. So some of the things we're focusing on for that are API stability, so making sure that all the APIs are correct and really, rock solid, and guaranteeing that like until Electron 2.0 comes out, none of the APIs will break. We're also adding more APIs all the time, so all those kind of native interactions I showed, we're constantly adding more of those as, say Windows 10 adds a new notification API, we'll like try to support that in Electron because it's like really valuable to use, the nicer, more, the new kind of things that Windows 10 can do, we try to backport them into Electron when feasible. We're also always improving the docs, so adding more guides, adding more tutorials, adding more information on how to get started. And we're also building a bunch of new tools to help you kind of kick off your Electron app and better understand what it's doing, what it's not doing, and like how to make it better. So we're working on all sorts of new tools that'll ship over the next month to kind of make the Electron experience even better for people building their first app. And the last two pieces that you may have thought is like, well, can I make some money on this app? So yes, you can take your Electron app and put it currently in the Mac store, and we're working on support for the Windows store. So say you want to build an app, you want to charge money, and you want to put it in the App Store, you can do that with Electron. So we do have a Mac App Store compatible build, and we've seen other apps already show up in the App Store, and the team at Microsoft is getting very, very close on allowing Electron apps to be put in the Windows store. So they're doing a lot of work on their end to support that, which will be great. And that'll hopefully happen in the next month. And I think we're going to be talking about it at that next meetup that I previously mentioned. And that was all I had for today. So thank you so much. The website for Electron is electron.atom.io, or if you just want to view all the repos and code, it's github.com/electron. It's also on Twitter at electronjs. So yeah, all that stuff is up there. I'll be hanging out after this if you have any questions. I also have some Electron stickers if anybody wants one. I think we have maybe 1 minute for questions. Cool, any questions?
Is there a common path for if you want to have like in a Slack has a web app, an actual web app, and also I didn't even realize that was Electron app, but is there like a simple way to get it? Like I have something that I was like a lot of users would probably like, and there's a path with this kind of app, but I would keep it as a web app also. Is that an easy thing to do?
It is easy. So that native IR library will kind of do some of that for you, but there's also a special like HTML element we have called WebView, which is basically like it's kind of like an iframe. So it's like a safe way to, because obviously when your Electron app runs, it has access to like the native file system, all sorts of dangerous stuff. You don't necessarily want your web app to be like compromised in a native setting, so we have a way for you to like lock down like a kind of iframe like thing and just say like load this URL and behave like a web app, but it actually runs in the context of an Electron app. So there are a bunch of good docs on that, and a native Fire library has some good descriptions of how to do that as well.
So is this Electron mobile compliant?
It's not mobile, so this uses Chrome and Node, and it probably will never run on a Windows phone or an iPhone or anything else because these native pieces just don't really, a lot of the interactions don't make sense there. So it's not a way to make mobile apps and probably never will be.
So how Slack is running then? Because Slack has a mobile app, so the mobile app is not on Electron?
No, yeah, I think all their mobile apps are native as far as I can tell. They probably share some like custom rendering libraries, like to do emojis and all sorts of stuff, but they're not. I don't think the iPhone app uses HTML, JavaScript, and CSS at all, from what I can tell.
Yeah. So does this one comply with the other browsers except Chrome?
Yeah. So really, it's mainly for like building apps. Yeah, where you want to lock it down to one version of a browser and like one set of APIs. So your app could keep running, like at that example, like I have a web app and I also want to ship a desktop app. You could just have your app use all those same libraries like jQuery that kind of paper over browser differences, but still they would still run in Electron. So it kind of depends on if you're starting an app, whether you're like, oh, I want to start a desktop app today, it's really nice to support one browser. But if you have an existing web app like you can keep it running in all these other browsers, and then it just becomes also like Electron compatible, since Electron is just the same as running Chrome 49, essentially. Cool.
You talked about the fact that you don't need to upgrade, that you can keep it at a certain level.
Yep.
I can understand how you can keep that.
Yeah, so that just means that like when we cut a new Electron release, like your app doesn't automatically pick it up. You control like what version of Electron your app ships with. I guess I may not have mentioned this, but your Electron supports automatic updates of your app. So you can like, you know, that typical like a Mac OS 10 thing where it's like a new version is available, install, skip, or remind me later. Like Electron handles that all for you. So you'll actually say like, oh, I see a new version of Electron comes out, it runs Chrome 50, let me test my app, and then decide, okay, I had to make a few tweaks, but now I'm gonna ship my users Electron version that ships with Chrome 50 instead of like Chrome 49. So it just means like you control the app update experience all yourself. But it's also really nice because we have JavaScript APIs for that. So you just kind of tell your app like, hit this URL for updates, and when there's an update, install and restart. So it's like that typical, you know, experience. If you've ever used Chrome or other apps that automatically update, it's a really streamlined experience where it just downloads the update, tells you that it's ready to restart, and you just click a button. All of that works the same in Electron as well. Cool, any other questions? All right, great, thank you so much.